Good morning everyone. I'm Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. Today we are going to discuss a very important topic in deep learning and applications called cleaning up incorrectly labeled data. So in machine learning, data is the foundation of everything. The quality of the data set directly affects the performance of the model. So there's a common saying in machine learning: garbage in, garbage out. This means if we provide incorrect or poor quality data to a model, the output will also be poor. One major issue in dataset is incorrect labeling, where data samples are assigned wrong labels. So this session helps us to understand what incorrect labeled data is, why it is occur, how it affects model performance, how to detect and correct it, advanced methods for handling labeled noise. So before going deeper into the topic, let us first understand why labeling is important. In supervised learning, every training example contains input data. So the information provided to the model, example image, text, audio, like that. Here the labels are the correct answer associated with that input. Example cat image, it shows the cat, and voice sample English. So this model learns by observing relationship between input and labels. If labels are incorrect, the model learns wrong patterns. So this creates confusion during training and reduces performances. This is why data quality is as important as model architecture. Your objective here is incorrectly labeled data refers to data samples that are assigned the wrong category or a target problem. Here this problem is very common in a supervised learning data set. For example, an image of a cat is labeled as dog, and a positive customer reviewed as a negative labeled. So what are the common mistakes happened because of human error, automation error, ambiguous data, which is samples that are difficult to classify, and then larger scale data, that is higher volume increases chances of mistakes. So incorrect label affect a model training, prediction accuracy and reliable. Here in this part, look at let us took at a practical example: image classification. A picture of a bird labeled as a airplane, and the model learns incorrect visual patterns. Here, sentimental analysis like review: this product is excellent, labeled as negative. So the model learned wrong emotional context, as like as in medical diagnosis as well. So, reduces first the problem with incorrect labels or reduce model accuracy, which means incorrect labels create multiple problems like reduced accuracy. It causes overfitting, and then create confusions, and then produce bias, which is the model may favor incorrect patterns. Example, detecting these issues become difficult in large data sets. So, understanding this scenario, let us consider a simple scenario. Suppose we are training a deep learning model for animal classification. See here, input as cat and an image of a cat, also with the dog. So, here an incorrect label as dog. What happens? The model starts associating cat feature with the dog classes. It learns cat ears, that is equal to dog. Cat whispers, that is also a dog. And then cat shape is which is resembles a dog. After many such errors, the model becomes confused. This lead to poor generalization, misleading training, and wrong predictions and reduced trust. This shows why label correctness is essential. Here, now that we understand the problem, the next question here is how do we solve it? The answer is data cleaning. Data cleaning ensures the data sets are accurate, reliable, and consistent. So without proper cleaning, even advanced deep learning models cannot perform effectively. Data cleaning is the process of identifying and correcting data set errors. It also involves major steps like detection, classification, correction, and validation. So detection is find a suspicious label. Verification is whether check whether the label is truly incorrect. Here correction is means assign the correct label, and validation ensures corrections improve dataset quality. So this semantic process improves training reliability. So what are the detection techniques? So there are several techniques for detecting incorrect labels, and the first one is outlier detection. So which means it find unusual samples that differ significantly. Example, a dark image among cat images, and the next one is a model-based detection, which means it train a model and observe high-class samples, and then cross validation errors, which means repeated misclassification identify indicates possible wrong labels, and then human review, it experts manually inspect as suspicious data. So high loss samples are especially useful indicators of label issues. And what are the correction techniques? Once errors are detected, correction begins. So first one is manual relabeling, which means human experts correct labels, most accurate but slower one. And second one is a major voting. Here multi annotators assign labels. Most common label is selected in major voting. And the fourth one is active learning. Here model identifies uncertain samples for human review. This saves effort. And then last one is semi-supervised learning. Uses both labeled and unlabeled data to improve correctness. So this is useful for large data set. And what is the working process of cleaning data is, first one, train initial model, and then identify high error samples, and then it review, check manually or automatically, and then assign proper labels, and then train again using cleaned dataset. This iterative process improves accuracy significantly. And what are the advanced techniques are assigned to tolerate incorrect labels? And then here deep learning filtering, it's neural networks identify suspicious sample automatically, and here in ensemble model, it multiple models validate labels, and if predictions disagree strongly, labels may be incorrect. And then last one is label smoothing. Here softens label confidence. Instead of assigning 100% certainty, slight uncertain is allowed. This reduces overconfidence. And these are the advantages of data cleaning. It improves model accuracy, better generalization, reduce bias, and enhance reliability. And applications are in real world applications, image classification ensures visual recognition accuracy, and here in medical diagnosis, correct label saves life, and speech recognition improves voice understanding, and in fraud detection detects financial fraud efficiency effectively, and NLP improves chatbot and translation quality. So every AI application depends on cleaning the data. And this shows the overall summary of today's session. So cleaning incorrect labeled data is a critical step in structuring machine learning projects. A powerful model with poor data will fail, but even a simple model with high quality data can perform exceptionally well. So always remember, better data creates a better intelligence. Thank you. Catch you in another video.